This will be the first episode of the lecture that we're going to have with analytical chemistry. So, in our lecture, we have discussed regarding percent mass, mole fractions, molarity, molality, and also normality. So, our first example is a solution is prepared by mixing 25 gram of sodium hydroxide with 1.5 kilograms of water. So we are going to calculate the following. Letter A, percent by mass of sodium hydroxide. Letter B, percent by mass of water. And letter C, mole fraction of sodium hydroxide. Letter D, molality of the solution. And letter E, molarity of the solution. And letter F, which is the normality. Now, we will have an assumptions of the density of water, which is 1 gram per ml, and then the density of sodium hydroxide is 2.13 grams per ml. The molecular weight of sodium hydroxide alone is 40 grams per mol, and the molecular weight of water is 18 grams per mol. So I'll just going to go directly to the solution. So for letter A, percent mass of sodium hydroxide. Sodium hydroxide. So as you can see, sodium hydroxide here is 25 grams. Then 1.5 kilogram of water. So how will you do it? When you say percent mass of sodium hydroxide, that means mass of sodium hydroxide over the mass of the solution, and then you multiply it by 100 because this is percent mass. So for the mass of sodium hydroxide, it's 25 gram. So that's 25 gram. However, the mass of water is 1.5 kilogram. So we need to convert this into gram. So in order for it to be with equal measurement of unit of measurement. So normally the conversion is 1 kilogram is equals to 1,000 gram. But this is for water alone. When you say a solution, that means it's a mixture of the solvent and the solute. So solute is 25 grams, then the 1.5 kilogram is for the solvent. So in that case, we're going to add 25 gram here because this is the this is the mass of the solution that we're talking about. Okay, so for our conversion, that will be 25 grams. Of course, the 1.5 kilogram, it's 1,500. And then you're going to add 25, so that's 1,525 grams. Canceling gram, multiply it by 100. Don't forget here also, you multiply it by 100. So your answer for this, let's check, 25 divided by 1,525 times 100. That is 1.639. Okay, percent. So this will be your answer for letter A. Let's go for letter B. What is as in letter B is the percent by mass of water. So we know that the percent by mass of the solution is 1,525 grams. That means the percent mass of water or the solvent is equals to 1,500 grams we have already converted the 1.5 kilograms. So that's 1,500 gram. And then the mass of the solution, which is 1,525 gram. Then you multiply it by 100. So the answer for this it's 98.361. 98.361. That's in percent. So that will be your answer for letter B. For letters C, mole fraction of sodium hydroxide. When you say mole fraction, that means mole fraction that's sodium hydroxide. So that means that moles of sodium hydroxide, you divide it by the moles of the solution. Alright? No, there's no need for you to multiply it by 100% because it's not asking for a percent. It is asking for mole fraction. So how do you do it? So how can we get the mole fraction of sodium hydroxide? To get it, we will going to use this and also this. Alright? So first, the moles of sodium hydroxide is equals to, okay, that's mass over the molecular weight, because for mass that's 25 grams. So the mass of sodium hydroxide is 25 grams, and then the molecular weight, let's go back, that's 40 grams per mole. 40 grams per mole. So we're going to cancel the grams. What is left with us is the mole. So 25 divided by 40, and that is 0.625 moles. Okay? So if we're going to cancel this and the grams from the numerator and then the denominator, mole here will be transferred to the upper or or to the numerator. So this will be the moles of sodium hydroxide. The problem is we don't have yet the moles of the solution. However, we know that the moles of the solution will be the moles of sodium hydroxide, then the moles of water. So 1.5 grams is, write this down first. Moles of water will be equals to 1,500 grams, because that's mass over molecular weight. Then that's 18 grams per mole for the molecular weight of water. And the answer for that is 83.333. So cancel the grams, then what's left for you is moles. Now you have the moles of water and then the moles of sodium hydroxide, which is your solvent and your solute. So we can now add it up to get the moles of the solution, which is 83.333 moles of the water plus the 0.625 moles for sodium hydroxide. So it will have both unit of measurement, which is moles. So the answer for this is 83.958 moles. So we can calculate now the mole fraction, which is moles of the solute, which is 0.625 moles, divided by the moles of the solution, which is this 83.958 moles. We cancel both unit, and then so that will be 0.625 divided by 83.958. So the answer for this is 0.00744. Okay, so this will be your answer. So now we're going to calculate what will be the molality of the solution. When you say molality, or this is the small letter m, it is the moles of solute per kilogram of solution. All right. However, what we have here, we have already the moles of the solute, which is 0.625. 0.625 moles. And then the kilogram of this solution, what we have earlier is 1.5 kilogram of, I'm sorry, that's not kilogram of solution, but the kilogram of the solvent. So let me just correct this. In that case, we have already 1.5 as our kilogram of the solvent. All right, so 1.5 kilogram solvent. In that case, the answer for this is 0.625 you divided by 1.5. That is 0.417. It is moles per kilogram is the unit of measurement. Now, for the next one is the molarity. What is the molarity? Or that will be the capital M. Remember, molarity is moles of solute per moles of solute per volume of solution. So the problem is we don't have yet the volume of the solution, but we do have the mass of the solution. Let's see. Mass of the solution is 1.1525 gram. So we're just going to use the density in order for us to convert it into volume. So the volume of the solution, which is as we can have, density is mass over volume, right? So transfer here, so that will be mass over density is your correct formula. In that case, 1525 gram. All right, and the density of the solution. So the problem here is we don't know what is the density of the solution. Okay, or the other option is we can convert the grams this of the sodium hydroxide, and then converting also the other one, the 1.5. What about we're going to try doing that, because the given that we have is not the density of the solution but the density of each component. So let's try to be clear. So let's just not use the volume of the solution, but the first thing that we're going to do is calculate the volume of the sodium hydroxide, or the solute, which is mass divided by density. As we know, 25 grams is the mass of the sodium hydroxide. Then the density here, if we're going to check it, that's 2.13. Okay, 2.13. Oops, I'm sorry. This is gram per ml. Okay, so let's cancel the gram. What's left is ml. Then we're just going to divide it by 1000 ml for 1 liter. So we can have the liters already of the solute. 25 divided by 2.13, that's 11.737. Then we divide it by 1000. So the volume of sodium hydroxide is 0.0117. It's just going to use this because 7 is a big digit already. So we're not going to use 0.012. Let's just do it in 4 digit. That's okay. So this is already in liters. What about the volume of water, the H2O? The H2O is 1,500 grams, but the density of water is 1 gram per ml. Then we multiply it by the conversion, 1/1000 ml. Right? So if we're going to check that, 1500 divided by 1, of course that's 1500 again. You divide it by 1000, it is 1.5. We're back. So that's 1.5 liters also. Sometimes you don't assume that 1 gram is equals to 1 ml, okay, for when it comes to density of water. Just always use the correct calculation so you can have exactly the amount that you're going to get. So if we're going to total this, that will be the volume of the solution. So that will be 1.5 liters plus 0.0117 liters. So, okay, 1.5117 liters. Okay, so we have already the volume of the solution. So for molarity, that's moles of solute over the volume of the solution. So big letter M, or the molarity, the moles of the solute, or which is the moles of the sodium hydroxide, that will be 0.625 moles. Okay. Then the volume of the solution, it's 1.5117 liters. So that means 0.625 divided by 1.5117. We have 0.413 moles per liter for the molarity. The last one is we need to find out what is normality. Okay? So normality is equal to the equivalent weight divided by we divide it by the volume of solution. Okay? We have here a correction for the calculation of normality because for the previous lessons or lecture that we have, we did not include the grams of the solute. As you can see, in this problem, we have 25 grams of the mass of the NaOH, right? So, in calculating the normality, we need to include this. So, the formula for normality, or capital letter N, is the equivalent of NaOH. Then we divide this by the volume of the solution in liters, or let's say liters of solution. Okay, the problem is we don't know how to or we don't have this one, the equivalent of sodium hydroxide. So this is how you get the equivalent. Okay. Oops, sorry. I apologize. So this is letter I, equivalent. So how do we get this? The first thing that you need to do is the molecular weight, we divide it by its number of equivalent. Okay, so let's say, for example, if that is sodium hydroxide, the number of OH here is 1. So OH is the charge of either be H plus or OH negative, or if it is only a salt, we're just going to determine what or how many charges each ion, the cation and the anion, to make it equal charges or balance. Like for example, NaCl, if we have NaCl, how many ions of Na needed to balance with the ions of chlorine? So that means this is positive, then this is negative. So for the whole compound, the charge for the whole compound is 0 because it's already balanced. Okay? So in that case, for the sodium hydroxide, we have only 1. But the molecular weight, we have 40 and 1. So this is going to be 40 grams per equivalent. That's the unit of ration. So that means for the normality, you need to calculate the mass for the formula should be mass, or the equivalent of sodium hydroxide, you divide it by the volume of the solution. But the equivalent of sodium hydroxide using mass is That's 25 grams earlier is the one that mentioned. And then you divide this by the equivalent weight. Sorry, this is going to be the equivalent weight of sodium hydroxide. So that's 40 grams equivalent per equivalent. Alright? So that means if we're going to calculate this, 25 you divide by 40, that's 625. That's 0.625 equivalent. And then that's not normality yet, okay? So because we're going to use the volume of the solution, so this is the answer for this. This is the answer for this solution, which is what we call the equivalent weight, or that's the equivalent of the sodium hydroxide. So okay, let's erase this. So as we know, that's 6.25 grams equivalent. Okay, so then the normality, that 0.625 gram do we need gram? Not yet, not anymore, because we have already canceled it. Equivalent. Then the volume of the solution, which is 1.5117 liters. So that will be 0.413 equivalent per liter normality. The other easiest way to calculate the normality using the molarity, that's normality equals to molarity multiplied by the number of equivalents, or the charge, which is, as we can remember, molarity is 0.413. Then the N here, or the equivalent, is just only 1. So 1. So you multiply it, then that will be your answer using molarity, capital letter M. That's all for this.